We are live. Hi everyone, welcome back to Codera. Today in this video we'll be discussing the LeetCode daily challenge for 25th of January. The problem name is valid mountain array. Previously this problem has been asked in Google and also this problem has been asked in Amazon, right? So consider giving me a +1 in the chat if my voice is audible to everyone and my screen is also visible, and then within a few minutes I'll start with the problem. Right. So this is a very easy problem, to be precise. Like you'll be given you'll be having to found, like you will be returning true in this particular problem when you will see that the array is a mountain array, right? That is, first of all, it might be increasing and then it might be decreasing, something like that. So if it is like that, so in that case you will say that yes, this is a mountain array. Otherwise, in any other situation, you will say that no, it's not a mountain array, right? So consider giving me a +1 in the chat if everyone can hear my voice and also my screen is visible, right? So in this particular problem, what you have to do is you'll be given, like, also if before starting, if you haven't subscribed our channel, that is Code Error, so you can consider subscribing our channel Code Error, because here daily we are putting in LeetCode daily challenge videos. Apart from this, Kabir is also taking live streams of FANG interview problems, and we have Ayush Gupta who is making editorials for codeforces, right? So in this particular problem, what you have to do is you will be given an array and you have to find whether that particular given array is a valid mountain array or not. What do I mean by that? So this means that you will be given an array of integers, right? You will be given an array of integer ARR and you have to return true if it is a valid mountain. So basically it means that when the array is something like this, when the array first of all increases and then decreases, so is this a mountain array? Yes, this is a mountain array. When, let's suppose, if the array is only increasing, in that case, is it a valid array? No, it's not. Why? What's the reason for that? The reason for that is because it's just increasing and it's not decreasing, so this is not becoming a mountain. If the array is just decreasing, in that case also it's not a mountain array, right? In that case also it's not a mountain array. And apart from this, what could be the other situations? So like you can say that if this is another type of array, something like this, if array is something like this, or let's say array is something like this, so you will say that all these are also mountains. No, these are not mountains. Basically in this particular problem you will not consider this as a mountain array. This will also not be considered as a mountain array. Only a mountain array would be considered when you, in the starting, your array is increasing and then after a while your array is decreasing, right? So you have a top point, peak point. Also there should be no plateau in between. Like let's say you are doing this and then this, right, and then dropping. So this is also not possible. Let me write it for you. Like equal elements are also not considered if there are equal adjacent elements, right? If you have something like this, so in this case also you will say that no, it's not possible, right? So consider giving me a +1 in the chat if everyone is able to understand the question properly, right? Is the question clear to everyone? Basically you will be given an array and you have to find whether that array is a mountain array or not. Now let's take out some examples, right? Let's say an example is 1, 2, 3, 4 and 5. So in this particular example, is this a mountain array? No, it's not a mountain array. What is the reason for that? I will stand here and I'll check for its adjacent. So for 1 I'll check it with 2. So are these two elements is the left element lesser than the right element? Yes. So I'll say okay, let me move to the next index. So I will move to the next index and I'll say are 2 and 3 lesser than, they have a lesser relationship? Is the left element lesser than the right element? I'll say yes. So I'll say okay, I'll move my pointer to the next element. So I'll move to this particular element. After that I'll say that is it possible that 3 and 4 are the elements such that 3 is lesser than 4? I'll say yes. So I'll say okay, I'll move ahead, and then what I'll do is I'll move here, and once I will move here, so I'll check whether 4 and 5 are having a relation like decreasing increasing relation or not. So they are having, so that's why I'll move ahead. And after that, when my pointer would be pointing at this particular direction, then for this particular 5 I do not have any element towards the right, so that's why I'll break here. And the moment I break, so I can check, I can see, or I can observe that my I is equal to n minus 1. Since my I is equal to n minus 1, so that's, what does that mean? So my, basically if this was the index 0, this was the index 1, 2, 3 and 4. So I can say that now since I am standing at the last index, so that means that I was only covering the increasing part, right? In this particular loop I was only going through the increasing part, and it makes me reach the end of the array. So that means that this particular array is not a mountain array, right? Another thing that could happen is, let's say you had 9, then you had 7, you had let's say 3, you had let's say 1, something like this. So in this particular case, if you are in this particular array, so is this a mountain array? No, it's just a decreasing array, right? So if you are here, so will you be able to move to the next index? No. Why? Because the relation between this and this is not where the left element is smaller than the right element, so that's why you'll not move forward. So I will be stuck here only. So you'll say that since your I is also zero after this particular loop, so that's why also you'll return a false, indicating that this is not a mountain array. Another thing that could happen is, let's say you had 3, 2, and then let's say you had 5, 6, 7, something like this, right? So in this particular case, what is happening, you can see you have a 3, then you are going to 2, then you have 5, 6, 7, like this. Okay, so this is also not a mountain. Let's say even if you had some decrementations like this, so even if you had let's say something like 4 and 2, something like this, so even if you have something like this, even then this is not the answer. Why? Because your I would be still stuck here, right? Because your I will not move. If the left element is lesser than the right element, then if you are checking for the increasing part, so this will not move, so I'll still be 0. If my I is, if I am checking for the incrementing part, that is if lesser element is if the left element is lesser than the right element, in that case, if my I is 0 or I is equal to n minus 1, in both the cases I'll return a false, indicating that the mountain array is not possible. Now another situation is that let's say I keep on going, right? Let's say I have 2, I have 5, 7, 9, something like this, and then I have 8, I also have 6, let's say 4 and 1, like this, right? So this is what it is, increasing and then decreasing, right? The 9 is the top element. So in this particular case, what I'll observe is, if I keep my eye at this particular point, so what is the relation between these two? They are like left element is lesser than the right element, so I'll say okay, I'll move here. Then I'll check for 5 and 7. Is 5 lesser than 7? Yes, so I'll say okay, let's move ahead. Then I'll say, is 7 lesser than 6? I'll say yes, it is, so I'll move ahead like this. Now I'll be at 9. Okay, so now my pointer would be at 9. So what I could do with this 9, right? I am at this 9, so now 9 is greater than 8, so I can easily observe that now I am not at the increasing part, so that's why I'll simply break and I'll check, is my I equal to 0? No, it's not equal to 0. This is index 0, 1, 2, 3, 4, 5, 6, 7. Is my I somewhere in the middle? Yes, it is. Is my I somewhere in the starting, like is it at the absolute start or the absolute end? No, so that means that there's no issue. So that's why what I'll do is, now I need to check for the decreasing part. Now if this much part is decreasing, is strictly decreasing, in that case I'll say that yes, if this much part, that is the left part from the index I am until the end, from this particular index until the end, if this particular part is completely decreasing such that my I could reach to this particular index, then in that case I'll say that okay, yes, it is decreasing, right? So that's why what I'll do, I'll simply put my I at this particular point. My I was already at this particular point, right? So now I need to I'll be checking for the left and right element only, but the relation that I'll be checking is, that is the left element greater than the right element, that is A of I greater than A of I plus 1, right? So it is, so that's why I'll move to this particular index. Now once I move to this index, so I'll check the relation between 8 and 6. So yes, I can say that A of I is greater than A of I plus 1, that is 8 is greater than 6, so that's why I'll move ahead. So from 8 I'll move to 6, right? From 6 I'll check the relation between 6 and 4. So since 6 and 4 are what? 6 and 4, I can simply say that yeah, they are, right? Up till now, is everything clear to everyone, right? So I can say that since 6 and 4 are the elements where you are having this particular relation, so in that case I'll move to 4. Once I move to 4, so what I'll say that what is the relation between these two? So the left element is lesser, so that's why I'll move ahead again, and my I would be pointing eventually to this particular point. And now since I just have one element, so that's why I'll always keep a check that my I plus, or like I plus 1 should be always lesser than n, like this, because if I have a right element, in that case only my last index is n minus 1, so that's why my I plus 1 should be lesser than n. This is something that I need to keep a check on, otherwise I would get a out of bound error or a runtime error, maybe you can say, right? So this particular part must be clear. So in the end, if I am able to increase, then I'm able to decrease, is that I've reached a particular peak, right? So that means that if my I is at the end n minus 1, after I have checked for the increasing as well as the decreasing part, in this particular case I will return a true. And if there is any other case, if I is not standing at the last index, if it is standing anywhere in between or anywhere at the starting or anywhere in between, so I'll say that it's false, right? Is this much part clear to everyone? Please consider giving a +1 in the chat, or like clear in the chat if everyone is clear with this particular problem, right? So else I'll write clear. Now, since I just traversed through the array, I just traversed through this complete array just exactly once. So that is why the time complexity of this particular approach is going to be order of n. And since we are just using a pointer, that is I, to check for the increasing part first and then the decreasing part, so the space complexity is order of 1, that is constant time, right? And just to remind you, this particular problem has been asked in a company like Google, and it's also been asked in Amazon. Now Amazon has also asked this problem a little bit with a little bit of twist. Like I think they had also one more question, like in which you have to find the largest mountain range. Like what does that mean? You have to find the longest mountain range. Let's say there are a lot of mountains in an array. If an array is indicating a lot of mountains, so in that case you might, if I ask you that was what is the largest range in which I am having the mountains, so in that case let's say this seems to be the largest range of ij, such that you have the mountain thing, so that's why you will print this particular length, right? So this is one of the questions that Amazon has also asked enhancively, so you can try it out. Now let me show you the code part for this particular problem, and the code is also available in the description. So also one more thing, if I have the problem suggests that if the number of elements are lesser than 3, in that case I need to return false. So after that I'll check n. What is n? N is the size of the array. If I plus 1 is lesser than n, why am I doing this? Because I do not want to overbound, right? For the last element, if I is at n minus 1, so in that case I will not have an I plus 1. So that's why I always need to keep a check that I plus 1 should be lesser than n, right? So that I do not end up getting a runtime. So if my left element, that is ith element, is lesser than I plus 1th element, in that case I'll increase my I and I'll simply continue, else I'll break. Otherwise I'll just keep on incrementing I, right, if it is perfect. So that's it. Now once you are done with this, like this if is not necessary to be written, if like this I plus plus is not necessary to be written. Now if my I is 0 or my I is n minus 1, so if I'm still at the starting or if I reach the end, so in that particular case what I'll do, I'll simply say that, right, that I'll simply be saying that if I have at the start or if I've reached the end, so that's why there's no mountain, so I'll return a false. Otherwise I'm checking for the decreasing part. Now what I'll check is I plus 1 is less than n, again I'll be checking, and if array of I is greater than array of I plus 1, in that case I'll say I plus plus, and I'll continue, else I'll break, and that's it. After that, in the end, I'll return I is equal to n minus 1. If I is equal to n minus 1, so that will mean that I have reached the end of the array, and the array is a mountain one, because first I'm checking for the increasing part and then for the decreasing part, so that's why I would be at the end, right? Is this much part clear to everyone? Quickly let me know in the chat if this much problem is clear to everyone, right? Is this much problem clear to everybody? Is it? Okay. So this was it. This was the problem of the day of Leetcode, that is Leetcode daily challenge for today. You can try to submit this problem, and once you have submitted it, so you can let me know in the comments after the stream is over that you have submitted the problem for the today, and also let us know your feedback in the comments. And you can subscribe the channel, that is Codera. We are trying to push in a lot of content that might help you, and we are trying to make Leetcode daily challenges. I'm also doing mastering codeforces binary search series, things like these. So you can suggest like what type of codeforces content you would like to see, so that I can make it. Thanks a lot for watching and have a good day.